Welcome back to the lab, folks. So today we have on the bench here a intelligent clamp multimeter from FNIRSI, and this is the FNIRSI DMC-100. This came out a little while ago. I think it's just been released in Canada just a couple of weeks ago, but it's been around for a short while. It's relatively new, and FNIRSI sent me one to have a look at, so that's what we're going to do today. We've got the unit itself. We've got some probes, we've got a temperature sensor, and a USB charging cable. They're probably good for doing firmware updates as well. All right, let's peel this back here, and let's turn it on for the first time. Alrighty, looks like it's got a pretty full charge, so I won't bother charging it up. Let's have a look at these probes here. Well, they're cut above standard. Very nice vinyl, I believe. Oh, gold plated. Nice and sharp. That's a standard type K thermocouple. And the manual comes in English and Chinese. Let me show you the specifications. You can either go online and download the manual yourself, or you can have a look at these. Freeze the frame. Probes go in down here. Do they match? They do. Oh, that's pretty good. All right, so let's go to ohms mode. We'll put this standard in, which we had a look at the other day. We know it's very accurate. Let's see what it comes up with on that. Nice, right on. 10K ohms. I've already determined that these are perfectly good for any meter up to 4.5 digits, and I believe that this one's only a 3.5 digit meter. And this should verify the resistor divider in it. 10.0 ohms, that's right on. 100.1, that's right on. 1000, that's right on. 10,000, that's right on too. And 100,000.1, that's well within specifications. Okay, let's put over to capacitance mode here. This I won't imagine is going to be as accurate, but let's have a look. 83 nanofarads. Well, it's supposed to be 100, but that's okay. Very good. Perfect. Very nice. Comes up 922, so it's a tad off there and down at the low end. Let's see about this 10 microfarad capacitor here. 10.1, it's right on there. I was keeping track of max and min here. That's a nice feature. Let me get the frequency generator up and running here. While that's booting up, we'll test the mains. 60.03 hertz. Now, what does the manual say this will go up to in frequency? 9.999 megahertz. We'll try it up there. 9 megahertz at 1.75 volts. That's right on. Let's see if it'll go over 10 megahertz. It will. Yeah, well, that's better than the specifications. Specifications only call up to 9.9999. Okay, I did find a firmware upgrade for it, so I did that. But I just wanted to point out in the manual here, there is an error. It says here you have to press the hold and the mode button and then power it on. And then you come to firmware upgrade. And then later it says you have to press the mode button to initiate the update. But in fact, you have to press the hold and the save button, not the mode button. And then when you do initiate the update, you press the save button again. Let's try out NCV. Yeah, it's picking that up. So you get a flashing blue if you're near the neutral and a flashing yellow if you're near the live. Let's try some DC voltages here. We'll compare it to the prime in here, which we know is a great meter. 4.204 versus 4.198. That is certainly within the specifications of this. Bring it up to about 30 volts. There's 32. Perfect, yeah, no problem at all. Bring it up to 60 volts. 60.025, 60.04. Okay, let's measure the mains here. Oh, they're both agreeing on that too. I can't fault it for its accuracy. It seems to be doing a very good job of that. Okay, we're set up here to measure current. We've got it coming down from the power supply, going through here, going through this meter in amps mode and over to the load. And let me turn on the power there. So, okay, so we've got about 0.2 here, we got 0.2 there, 0.66, 0.66, 1.8, 1.8, 6.16, 6.22. That's close enough. Let's have a look at an interesting mode. It's got what we call a power mode. And I've got a set up here so you can see that a little bit better. Okay, to do power measurements, you need to have the probes attached. So we're going to measure the voltage coming out of the power supply. And I think you have to long press this to get into the power mode. Okay, there we are. Now, let me zoom in down on that. All right, and the power is right there in the middle. And they make it very, very small. What I would like to have seen them do is make amps a little bit smaller, volts a little bit smaller, and then have the power about the same size. It'd be easier to read. But let's measure the voltage here. Okay, so we've got 8.38 volts, 4.15 amps, and 34.8. That's right. That's a pretty handy mode to have. And another nice feature about it is that you can save values. So if you press the save button, it saves whatever you're measuring at that point in time. So let's go back to current here. So we can save the 4.15 or whatever it was when I pressed the button, and then we can set a different value, and we can save that. We can measure another different value, and we can save that. And then if I press the save button for a long period of time, we get into the settings mode, and here you can see all the different values that I just saved coming up and down along here. That's a nice feature as well. In here in this settings mode, you have the typical things like language, factory reset, and of course your information page. We're at version 1.3, which is what I just installed. It came with version 1.1. And it's also got this little graphic mode. Just long press the mode button, you get this display here, and then it'll provide you with a little graph. So we're just measuring some DC voltages here, and I'm varying it up and down. You can see how it displays that. That could come in real handy too if you have something that is varying. Alright, so let's try this Schottky diode. 0.26, close. 0.62, lights up the red LED. 1.75, lights up the yellow LED. 1.856, lights up the green LED. 2.33 volts. And the blue LED at 2.549. Perfect. Let's have a look at continuity. It's very quick. It does seem to be latched, but not for a very long period of time. All right, let's see what resistance continuity kicks in at. We've got it at 100 ohms, and we're not beeping. 90, 80, 70, 60, 50. So that's it. Anything less than 50 ohms, it'll kick into continuity. Also has a flashlight. Enough. Let me turn off the lights here. Could be okay for letting you know when you're putting on some wire or something. Okay, the last thing for me to check here is AC current. Okay, what I've got here is this little heater set on low. I know from previous experience this draws 3.8 amps, thereabouts. My power fluctuates here a little bit. So let's get this set up into amps mode, and we'll go for AC amps, and we'll clamp it onto the 1 times coil here. See what we get. 3.74 so on the 10 times here. 37. Very good. We've checked out everything on the meter now. Let's summarize. Okay, so what do I think of this little meter? I like it that it's compact. I like that it has rechargeable batteries. I know a lot of people don't like that, but I particularly do. I like all its features. It's got some more features than what my little Uni-T UT210E does. So I'm actually going to replace my Uni-T with this. And my Uni-T is going to go up for sale or giveaway. I really like that power mode, where you can measure both amperage and current at the same time. And everything seems to work just fine on it. It meets some specs, beats other specs. It's not one thing I found where it actually really came short. So yeah, I can recommend it. I'm going to use it here in my lab myself. It costs about $46 Canadian, so I think it's a bargain for that. The only thing I'm a tiny little bit disappointed in is that It didn't come in a nice FNIRSI case that they seem to be putting on everything these days. I've got a case here I can put it in anyway. Thanks FNIRSI, and yeah, recommended. Glad you guys came out to see this video. Hope it helps you make a decision, and we'll see you in the next video. Bye-bye.